You know, when you think about programming, do you picture just endless lines of complicated code? Well, what if I told you it could be way more intuitive, and honestly a lot more fun? Kind of like playing with building blocks. In this explainer, we're going to dive right into that.
So, take a look at this butterfly. It's not just a picture, right? It's interactive. When you touch it, it changes color and size. But how? How does it know to do that? That's the cool little mystery we're going to solve today using the simple but super powerful ideas behind a tool called Scratch. See, the whole secret to Scratch is that you don't really write code, you build it. You just snap together these colorful blocks, just like digital Legos. And every single block has a unique shape and a very specific job to do, and the way they click together basically tells you how they work.
Every story has to start somewhere, and every program needs a trigger. In Scratch, that trigger is a hat block, and it's named perfectly. Just like a hat goes on top of your head, these blocks always sit at the very top of a stack of commands. They're the ones that tell everything below them, okay, go.
And what's so smart is the design of the block itself. See how it's smooth and rounded on top, but it has that little bump on the bottom? That shape is this brilliant visual clue. It's telling you, hey, nothing can snap on top of me. This is always where a script begins. It's like the starting pistol for your code.
So, if hat blocks are the starting pistol, then stack blocks, well, they're the actual race. These are the workhorses. They are the action words, the commands, things like move, say something, play a sound, or change color. And they're designed to stack perfectly, one after the other, creating a clear to-do list for our characters to follow. And this is where that Lego idea really clicks into place. Notice the notch on the top and the bump on the bottom? That design makes sure the blocks only fit together in ways that make logical sense. You're not just typing random commands, you're physically building a logical structure, which just makes it all incredibly intuitive.
Okay, so we get how to give a program a simple to-do list, but what about making our programs, well, smart? How can we get them to react to what's actually happening around them and then make choices on their own? This is where things get really creative.
For any program to be interactive, it needs to be aware of its world, and more importantly, it has to be aware of you. Sensing blocks are basically its eyes and ears. They're constantly asking these little questions in the background, like, is the mouse pointer touching me right now? Or, hey, did someone just press the spacebar? The answers to those questions are what let the program react in real time.
So, once our program can sense things, it needs to make a decision. And honestly, there's a perfect and kind of delicious way to think about this. An if-then block is a simple choice. If mangoes are available, then we make a mango shake. That's it. But an if-then-else block, that gives us a plan B. If mangoes are available, then make a mango shake. Else, we make cold coffee. It creates two totally different paths for the program to follow.
All right, so our program has senses, and it can make decisions. Awesome. But what if we want it to remember something? Like what if we wanted to keep track of a player's score, or maybe remember their name? For that, we actually need to give it a memory.
And that memory comes in the form of something called a variable. The absolute best way to think about a variable is just as a labeled box. You can put something inside that box, a number, a word, whatever, and the program can go and look inside that box later on to see what's in there. It's basically the program's short-term memory.
And making one couldn't be easier. You literally just tell the program, hey, I need a new memory box. Then you give that box a name so you can find it later, something simple like favorite fruit, and that's it. You've got a spot to store information that your program can use anytime it needs it.
And here's a perfect example of it in action. The penguin asks question, what's your favorite fruit? It then listens for your answer, and whatever you type, it puts that information inside that favorite fruit variable we just made. Now the program knows your favorite fruit. It can use that information later on, maybe to have the penguin say, oh wow, I love mangoes too.
Okay, now let's imagine you want a character to, say, spin around 10 times. You could drag out 10 separate turn blocks and stack them up, but that's a ton of work. And programmers, well, we're always looking for a smarter and, let's be honest, a lazier way to get things done. And that's where loops come in. In Scratch, you'll hear loops called C blocks because, well, they're shaped like a C. And this shape is another piece of fantastic visual design. You take the blocks you want to repeat and you just tuck them inside the C. The loop then takes care of the rest, running those blocks over and over for you. This is the real secret to animation and making things happen automatically.
Now loops come in two main flavors. You've got the repeat block on the left, which will run the code inside it a specific number of times, say 10 times, and then it stops.
But the forever block, on the right, that one's different. It will run the code inside it continuously, in an endless loop, and it won't stop until you manually hit that red stop sign.
Okay, so we've got our starters, our actions, our senses, our decisions, memory, and repetition. We officially have all the tools we need in our toolbox. So let's put it all together and build something cool.
And here it is. This is the complete script for that interactive fidget spinner. Now I know at first glance that might look a little complicated, but don't worry, we've actually already learned about every single piece of this puzzle. It's just a clever combination of all those simple blocks we've been talking about.
The real magic is just in how they all work together. Let's trace it. The when green flag clicked hat block starts everything. Then that forever loop makes sure the program is always listening, always checking. And what's it checking for? That if-then block is asking, is the mouse touching me? Is it? Is it? And the second the answer is yes, then the action inside, that repeat block that turns the spinner, gets triggered. Each block has one simple job, but together they create this really fun interactive experience.
And that right there is the big takeaway. Programming, at its heart, isn't really about memorizing a bunch of complicated words. It's about understanding a few key ideas, like sequences, loops, and decisions, and then combining those simple building blocks in creative ways to solve problems and, make cool stuff.
So we've seen how these are the building blocks for a simple game. But that leaves us with a bigger question. What else in our digital world is built from these exact same ideas?